Yeah, thank you. I didn't say anything yet, so just a little bit before. Okay, thanks everyone to be here. It's really a pleasure to come at Data Bay to talk about what we do in agile data science and specifically dedicated to genomics information systems, right? So right now I have 2 talks in a row. The first one will be about interoperability of systems in genomics specifically. We'll talk about something called global analytics for genomics and health. I will give a few words about it. But before that, so Datafellas is actually, it's a Belgian company so far. We are creating right now the entity in the US, and we expand our market over here. And what we do is that we enable data-driven businesses by allowing data scientists to be more, productive thanks to agility. And the toolkit that we are creating is allowing them. And in the right-hand side, you have every shortcuts. But the main topic that we are doing is data science on data science. So I'm Andy Petrella. I used to be the gorilla. I have a mathematical background. I did a lot of geospatial data analysis in my professional life, let's say. I created my own distributed computing 15 years ago to do this kind of things. I created the Spark notebook. Who knows Spark? Great. Who knows the Spark notebook? Okay, cool. I mean, yeah. I'm a trainer for Scala, Spark. I gave a training with O'Reilly on distributed pipeline a few months ago. And my buddy, Xavier Tordoir, with whom I created the Datafellas, has kind of same background in physics, bioinformatics. He created also his own distributed computing a while ago. He's a Perl guy initially. Genomics is about Perl actually. So, we both did a lot of machine learning. So, okay, the lineup is GA4GH, GA4GH, Scalability, a bit of infrastructure architecture, what is a catalog, and the extensions that we might foresee. So, what is GA4GH, right? So, genomics for aliens for genomics and health, okay? So the thing is, it's a kind of framework, if you like. It's like W3C, but for genomics and health, right? So they are there to create standards on the data and so on. So not only genomics, but also clinical data. Why? The idea behind that is that we want to make advances faster in genomics and health, right? In order to do that, we need to be able to share information in an efficient manner and in a clean manner as well. I don't mean that the data is clean, but the way you will share information is at least clean. How we do that? Okay, so we define interoperable services and types. I don't know if you guys are really familiar with geospatial, but this kind of things exist for 30 years in geospatial, right? So now it's time to have it as well in bioinformatics and genomics and health. So who is GA4GH? It's 300 plus institutions mixing research, healthcare, also very big enterprises like Google, Amazon are there, right, in order to move forward a little bit faster with their footprint. Okay, so there are a few working groups out there. Clinical, which is more dedicated to the data itself, so what kind of data we can share. The data group is about how we can represent the data and share it. Regulatory and ethics, they are there to say, okay, what we can share and what we cannot, and in which ways, if necessary. Security is the protocols, mainly on the protocols. So if we can share this information, what are the constraints and what we have to respect in order to be able to share it. So this is not, I mean, they're not joking, right? So they're taking it seriously. Why it would be that important to have something like that? I mean, the data available right now is huge. So we are now at more than 100K genomes, that was last year. We target 1 million, and very soon it's going to be 10 million, and of course, we target the 10 billion. We cannot really go beyond that because we're not that much, but I mean, this is something that will still growing. And I'm still talking about the genomes, I mean, the human genomes there, right? So the many genomes that you might also take, like environment, bio, and whatever, right? But the idea is that what if we could query these million of genomes, which are pretty huge, right? What could we discover based on this, huge information that we have available right now? And the idea is that not only the genomes are important, as I said, but also we want to mix it and merge it with many other data sets like imagery, PET scans, and things like that. Also being able to include real-time, like monitoring, okay, so how we can correlate both things. And of course, one important thing right now with smart cities and so on, environmental data can be something very interesting to mix up, how to see if there is a correlation, for instance, between genome mutation and environment changes, for instance. Who knows, right? So in order to be able to do that, then we need to be able to query the data and to make sense out of it, right? So we need to be able to query it at least. So not only one data set, but all of them at once, for instance. In order to be able to query, so we need to be able to know which query we want to issue. That means to be able to discover it, right? And it is a very difference between discovering and querying, right? When you query, you know what you want to get back, more or less. When you discover, you shoot in the shadow, right? So you need data to be distributed, and we need, of course, to have systems to be scalable. Okay, so what is about distributed systems? So our Spark, right? So we don't want to copy the data, we want to work on partitions, and we want to follow the protocols. But of course, we want to do that without any complexity or additional complexity. Who works with HPC? Okay, so you know how great it is, how easy it is, to manage, to schedule, and so on. So it's a very hard to work with this environment. Now Spark puts in some sense a layer of facility, or it's more easy now at least it's easier now to work with this kind of systems. Right, so I'm going to give a short information about Adam. Who knows Adam here? Okay, a few of you guys. So Adam is a layer for genomics information, right? So Adam is part of the big data genomics project in AmpLab, and it's composed of many things. This big data genomics, you have Ego for the data sets, Avocado for the variant caller, Adam for the core API, and the I/O. So how to be able to query the data and how to store it, right? And BDG formats is one of the most important one. Those guys are the types, the schema, right, dedicated to genomics. And the thing is that, so we need schemas, right? We need schemas because for who knows VCF, JCF, BAM, and SAM, and so on, those formats are not suitable for distributed computing. Why? Because they are big data sets. It's like a big image, right? So you cannot really easily compute things on a big image because you require a lot of shuffling. You need to share a lot of information in order to be able to do that. And we need to be able to rethink the way we are storing the data or producing the data, right? So that it can be stored in a efficient manner in a distributed system like HDFS or S3 or whatever, right? And how to do that, so there are many manners to do that, but they took in Adam the Avro protocol, let's say, right? So in Avro you can define schemas, so you define the overall information that you want to share, and behind that you don't define the storage, but it can be distributed. But the thing is that what is really cool is that not only you can define a schema for the information in and out, but also you can define schemas for the methods. So who worked with SOAP? Right? So Avro is like SOAP, is a beefed up SOAP if you like, right? So SOAP without XML. Okay, so you target a system, you say, okay, what kind of operations can you do? Okay, I want this operation, what types do you take? What types will you send to me? Okay, so this is essentially what it can do. And it's part of the protocol as well. It's not schemas that are outside like in SOAP, so it's part of the protocol, right? So as I said, so Adam defines strict schema, and you can store the way you like it behind that, and the idea is to store it in a partitioned way. So, so you can provide smart interfaces and so on and so forth, but the interesting thing is that in big data genomics in AmpLab, which has been renamed now RISE or something, I can remember the exact name, anyway, cool. So the thing is that they are now on top of that creating a few machine learning algorithms or real, how to say that, well-known analysis like Mutect, some visualization as well. They do very good at that. Variant calling, so it's necessary in order to extract the right information over there. De novo assembly and so on and so on. So they are working now not only in the, so they are on one level up, right? So they define everything below, and then now they are able to do very awesome things with that. So in the next talk, I will give a little bit more information about that. So I would have liked to swap them, but yeah, it's hard at the last minute. Right, so Scalable Server now. So what about, we described Adam, and now we get back to GA4GH. So they are there to share information efficiently, to provide the right methods and so on. So how could we do that? Since we have this amount of information available and we want to share it efficiently, it's better now to maybe have a server which is schema oriented. Why? Because then you can ask your laboratory and you ask another laboratory what kind of data you can have and how they can query it, right? And it doesn't have to share, how to say, they don't have to take a text file back and then parse it in its own way, right? You just take the binary format and the protocol handles it, right? And it has regular types in his hands. So there is no, how to say, communication involved in here, and certainly not human. Okay, so it defines formats for the data, but also for queries. So this is something looking like Adam, but in a more interoperable way, okay? So they have a multitude of services, one for the reads, which is the small information that we can have in the genomics, in the genome. So when you read information, the bioinformations, the variance, sorry, and also, it's not there, the genotypes, but anyway. And beacon is something more for metadata. Right, so I'm proposing just in small architecture, something that we have implemented in DataFLS. It's still open source right now, but it's mainly, able to implement these protocols in a very scalable way thanks to Spark and Adam, right? Because those guys, in GA4GH, they have implemented these services, but using Python, local scripts and so on, so it doesn't scale really well. And now what we propose is that using Spark instead of Adam, for instance, in order to do that. Because then not only you will be able to store the data efficiently or to compute it efficiently, but also you will be able to use the new algorithm available in MLlib or H2O or whatever libraries that are coming right now in the area of data science, let's say. So you can have this kind of microservices orientation. So maybe one service is targeting only one method, or you gather the method together in a more semantic fashion. But the idea is that you can have multiple microservices serving one purpose, and then you can expose there your Avro RPC, which is essentially like SOAP RPC, right? So just a port which is open where you can target, you can issue a query like what kind of operations do you have, and then the protocol goes down. But the thing is that you can also expose it in a REST API if you like it. Right, then you enter a uncertain area, I would say. But you can add authentication, UI, and so on top of that. But the main thing is that on the back end, you can use the data source API from Spark to do that, or you can use Beam or whatever you like in order to access the underlying system that holds data, right? And if you don't want to move the data from the old storage, the silo storage where they have terabytes of data, and new thing is it can be efficient, then you can have a protocol from the FPT layer that goes through the data layer, and somehow you can cache it, for instance, in Tachyon for a little while, right? So you have a small process that will handle the data and push it into a cache. Like I still think about Tachyon like a cache. I kind of like this, to think this way, actually. And yeah, and if you want to have a persistent cache, then you can use the underlying file system capabilities of Tachyon to store it in Cassandra or whatever. So, but I mean, this is a successful implementation so far. We'd like to also push it further. But yeah, this is essentially what we propose. So our implementation is very scalable. So we tried with 4 nodes, 40 nodes to do some analysis, the thing that we'll talk just right after. But the thing is that the processing is mainly based on Spark and Atom, but also we are enabling extensions, custom queries now. Okay, so the standards are okay, so everybody can use them, and it satisfies like 85% of the use cases. But I have also internal models, so I have internal processes that I would like to expose. And in order to do that, so you might want to add an extra microservice that will do that. So you expose your service and have a schema, and then other laboratories can hit this server, know the operation, know the types, know the outputs, and there is no communication involved, right? So you can expose your own stuff, custom queries, to anybody in no time. So you don't have to share anything. And then you can plug in data sources as shown. So right now we have implemented what was very important for us, which is variant information. We didn't go to the read yet, but we have implemented like half of the standard in a few weeks at that time. However, so now we have services everywhere, right? But it reminds me the time where internet was, FTPs, and you had to know exactly the address of what you wanted to consume, right? So it's pretty much like that now. You have laboratories, you have institutions everywhere in the world. That means that how the heck could you know where the information is? Where the data is that you want to consume for your own purpose, right? So now you need to be able to discover not only the data, but also the services. So you need to be able to catalog this information. Right? Data and services. So the idea is how do you know where to query, which custom queries can be available, and which ones are more important for me than the others. And then, as I said, so we need a search engine for this kind of services, like Google was, or at that time Yahoo and other services, Alta Vista as well for the others. So that's why we have this Genomics Catalog, and the idea is to extend GA4GH with extra capabilities that allows to support metadata queries. That means that a schema is describing service capabilities, but also it's also describing data set. That means that you should be able to target, to issue query to a catalog saying what kind of services right now, where it is deployed, about variants for this population in this range. Okay, so you should be able to do that, and not targeting each institution and one at a time, but target this catalog, and they say, okay, this service is there, and there, contains the right information apparently, so you can then issue the right query in the right manner, right? And they may have different version of the services, and you don't care because the protocol is handling that, right? So the versioning is in there as well. So in order to do that, you need to have harvesting operations. That means that you go from one service, and then services can reference each other, and then you crawling the web of services this way. So it is pretty much like that. It's done in geospatial, for instance. So the data is always connected, so there is a way to do crawling in there. And finally, define a few queries that allow to search efficiently the data and the services into this catalog. So this has to be also very standardized. So the approach to do that is that in order to be able to do these custom queries, what we do in De La Felas, as I said, so we want to enable productivity. So instead of having the data scientist doing his work and then converting his work into a project and a service and Avro and so on, we do it for him. That means that from the notebook, we compute the job, we create the Avro schema for the types, for the Cassandra layer table, or for whatever HDFS information they have stored. And also we are building this knowledge base in order to be able to query information and services internally. So it looks like that. Actually, I will go through because I just have 30 seconds. So we have the notebook, and then we click on deploy. So you define a few things like I would like to name this like that. What is the version? Then you deploy the project. This is deploying a project, a job in Spark, like Mesos Chronos, for instance. This is to define the service. Then you end up with two services because there were a Cassandra table. So you will be able to expose a model, but also the information. And then we have integrated this search panel right now that where you can search what kind of data you are looking like, and then it returns jobs, services, and so on. But now the idea of data science on data science is that you don't need to use this thing anymore. Because while you are typing your work in the data book, in the notebook, then we will be able to discover what you want to use and maybe proposing maybe this data set or maybe this service or whatever. So this is reversing the way you will use catalogs and data lake, for instance. And when you click on a service, then it loads the schema and then you know what it can do. So yeah, so I'm done actually. So this is an article that you want to look where sharing is important. We need you, of course, to do that and to go beyond what we have now. And this is pretty much it. So there's a genomics on steroids, right? Thank you.
Qualification of people are looking for.
This is no, this is me 10 years ago actually.
Thank you.
Yeah. If there is any question, I'm open to. Yeah.
One thought, just to share. If I look at your catalog,
Yeah.
I've been working on service as well. I think probably under deliver what maybe the potential you can have if you do have that catalog. Because if I have a task I want to do, I probably don't want to bother even go to look for the service. I would rather just say do the job for me. It's the best way I can do.
Which job? Which kind of job then?
If I have a genome related things I want to do like task, and with what you have there, it's a infrastructure. It's best for me not to worry about underneath what service I should look for. You send it for me.
Exactly. Yeah. This is the idea. So we can send the service, but then I mean this is your task to decide if this service is very accurate for you or no. And when you consume the service, you might want to know, okay, is the data accurate enough for me to consume for my own project? Yeah. So what you can do then is that, because we are doing that in our product, is that you want to maybe go one step deeper and see what were the sources that were consumed in order to produce this data set. And then this concept of line edge is important too.
But that's tied up with the server, probably is too technical.
Yeah.
Probably would say whether this is a good source, rank it for me, and make a suggestion for me.
Yeah, sure. You can do it, but then it's your decision to use it or no.
Now, another concept, I have been doing something similar in different domain. Yes, schema will be helpful. Catalog really, for me, strikes more like they have a very good, it's a good protocol.
Which one?
Avro,
yeah.
And it's really addressing this serialization.
Yeah. Not actually, yeah, for in the protocol, yes, yeah, exactly, yeah.
And so from the domain you try to address, that's actually less important.
No, it is really important because just stay there and watch the next talk then, okay? Because I'm going to talk about it right now, okay? About the schema importance and yeah. But it's a good question. So I'm going to just talk about it right now.
30 minutes.